In this video, we will be doing some more linear inequality problems. In my last video, we have seen that whenever x minus a and x minus b is greater than 0 and we have given that a is greater than b, then we got the solution as either x is bigger than a, the bigger quantity, or x is smaller than b, the smaller quantity, because either they both are positive or they both are negative. Simultaneously, we cannot have the two quantity. Now, using this as a formula, let us solve now the following questions. So, the question 1 says x square minus 4ax plus 3a square greater than 0. X belongs to real, a is a parameter, and of course we want to solve for the values for x. Let us first factorize. This is a quadratic equation in x. So, we will write x square minus 3ax minus ax plus 3a square is greater than 0. So, from the first we will take common x minus 3a. From the next I will take a common. So, this is x minus 3a greater than 0. X minus 3a into x minus a greater than 0. So, now 3a and a, I got something expression like this. So, we have a, we have probably this as b. So, we can see that 3a and a, these are the two terms that we got. But we do not know what is the value for a. A is negative. If a is negative, then minus 3a is smaller than minus 1 because it is 3a into a. If a is positive, then plus 3a is bigger than a. So we have to consider now the cases depending upon what is a. So we now have to consider the cases for a. Let us take the first case when a is positive. If a is positive, then 3a is bigger than a. In this case, the solution will be that x is bigger than 3a or x is smaller than a. This is one solution. If a is smaller than 0, if a is less than 0, in this case 3a is less than a. So obviously in that case x is bigger than a or x is less than 3a. This would be the case. The third possibility is that a is equal to 0. If a is equal to 0, in this case, from the given statement itself, from 1 itself, you can say the question is now x square because a is 0, so this term is gone and this term is gone. X square is strictly positive. Now x square is always greater than 0 except in the term when x is equal to 0, because if x is 0, then the square of that quantity is also 0. So x belongs to real minus 0. You can subtract this 0 quantity, or you can say x belongs to real except x is equal to 0. So that is the third case solution. So we got these three solutions for the problem number 1. Now in the second problem also we want to solve this. So take everything on the left hand side and we get minus 3a plus 4 times x is greater than 0. Now let us make the factors of this statement quickly. Rewriting this as x square minus 3a plus 4 into x plus, from these two terms take 2a common. So this is 2a, a plus 4. And from there we can see that already this 3a you can write it as x square minus 2a plus a plus 4 into x plus 2a into a plus 4 greater than 0. So we can see that a plus 4 is here, 2a is here, and it is a product of these. So we can make the factors. We will get x minus 2a into x minus of a plus 4. I have directly made the factors now. Now again there are two cases. X is bigger than the bigger quantity or x is smaller than the smaller quantity, but we do not know what is bigger, 2a or a plus 4. So we will have to make three cases again. What happened when 2a is bigger than a plus 4? In this case, if 2a is bigger than a plus 4, so we will get the answer as x is bigger than 2a or x is smaller than a plus 4. But in this case, the value for a is also 2a minus a is greater than 4. A is greater than 4. So for a strictly greater than 4, we have this case. For the case 2, when 2a is less than a plus 4, in this case we will get a is less than 4. For a less than 4, we will have the opposite case, that x is less than 2a or x is greater than a plus 4. This would be the solution. Third case, it is greater than 4, it is less than 4. Third case, when 2a is equal to a plus 4, or we say a is equal to 4, this is the third case. In this case, from the statement, we can see that this is x minus 8 whole square greater than 0. And again, since it is positive, So for and we are taking square, so obviously for all real number it is valid except when x will be 8, because whenever x is 8, this square quantity will become 0 and we want it strictly positive. So for that case we have this as a solution.